welcome back. So this is going to be like a part 2 of clustering, where we are going to look at the other mode of clustering, which is individual interface mode, right? On the screen you see we have two devices, R1 and R2, and we also have a similar kind of a setup where we have the ASA1, ASA2, right? The main difference here, what you see is we don't have the port channels which we had earlier, right? And we're going to use routing instead of the port channels to accomplish our goal. And our goal is basically to load balance the traffic so that you can use multiple ASAs, club them together, and balance the traffic going from R1 to R2, right? So that's our goal, and we're going to achieve that without using port channels though. This is personally, if you ask me, this is not a preferred way, I would say, right? And there is no port channel as well, right? Nevertheless, we will do a demo of this, and we'll see how do we get around this. To start with, let's do the most of the configuration which we did earlier still stays, right? There will be like slight differences. So I'll probably take the earlier configuration which I did over here, and I'm gonna do changes over there so that we don't have to type in a lot, right? So let me pick that up first. Right, so this is what we did earlier in my the other spanned mode of clustering, right? So let's start with this. So what are the changes, right? To start with, the switch. So we normally go and configure the switch because this is our logical topology and this is our physical topology, right? And we have to convert this into this. So how we do that? We're going to start with the switch, right? So all of these devices, 1 2 3 4, all of these 4 devices are connected to my switch, right? And so if you look at here, we have like two VLANs. One is VLAN 10, one is VLAN 20. On VLAN 10 we have the interfaces, which is going to be so we have 3 interfaces on VLAN 10, right? The router interface and 2 of the ASAs. Earlier we had port channels. We need not create port channels this time, right? So what we are going to do is so we can remove the port channel part, and so these 2 interfaces used to be in the port channel. I'm just going to club it here in the first line itself. I can remove this. I can remove the port channel as well, which I did earlier, right? Similar is the case for the VLAN 20 as well, right? So let me put this as no shut here. Okay, so similar is the case with VLAN 20. Let me just pick up the other 2 interfaces, because even at the top, just like here, we need to have 1 2 and 3 interfaces connected in VLAN 20, right? So let me do that. Okay, so yeah, so it's going to be just picking up these 2, and I'm going to put them up here, right? Let's remove this. Let's remove the port channel, and let's do a no shut here. Okay, looks good. And the cluster link basically still stays. We still need the cluster link like how we had it earlier, so we'll retain it, right? So this is going to be the only configuration on my switch, right? I can actually take this up and put it right away. So this is my switch. Let me like clear the screen a bit. Okay, that does look good. Sweet. So that was basically the configuration on my switch. What do we do next? Let's finish the configuration on my routers, right? Let's do that. Yeah, so on my routers, okay, the only change here is that I'm using my gigabit internet, for this particular so I'm gonna just do that. I'm gonna change this Ethernet to gigabit, right? Because I'm using gigabit over here, right? I think I was using Ethernet in the earlier video. So other than this, what do we have to do? So we have this. Maybe let's create a loopback interface on both the sides, right? Let me create the loopback interfaces on both my routers. So let's put that here. Okay, let's do that. So on both my R1 and R2 I have my loopback interfaces now, which is good here. Okay. My bad, let me copy it again. Okay, that looks good, right? Wonderful. Now, like I said earlier, what we are trying to do here is we're not gonna use port channel, but we are gonna use routing protocol. So we are gonna have EIGRP on all my three devices, my routers and my ASA one, right? R1, R2, and ASA, right? I'm gonna put my routing protocols. Uh, I'm gonna show you how I'm gonna do that on ASA later, but let me do it on my R1 first, right? So let's start with R1. So let's just take this and put this as well. Okay, so that's my R1 here. This is my R1. Let's put this R1, and let's also do it for R2, right? The routing is pretty simple. It's nothing but the EIGRP routing, where I have a autonomous system and I'm basically advertising my routes, which is 10 network because it is R1. This is the 10 network, right? We have 10, and the loopback is 1.0.0. On R2 I'm advertising 192 network in the 2.0. The other thing which I need to do here is I have to set the hello timer and the hold, okay, just the hold time I would say. So let me do that as well. So if I go to my interface here, once I've configured my routing, I can go to my interface and I can set my hold timer. Hold time is very necessary because we are here trying to talk between the routers and the ASA, so it's better we have a decent hold timer set, right? Otherwise we'll basically end up losing the adjacency very often. So let's do that. Let me do that on R2 as well. So there you go to the interface, and I need to mention IP hold time, EIGRP autonomous system 100, and the 40 seconds is basically the hold time, right? So that is all the configuration that would go inside R1 and R2. Let's just quickly take this up and put it on the device. R1, meanwhile let me pick the second one as well, which is R2. Let me pick it up here. All right, looks good. So R1 and R2 are set. What do we do next? The only thing which is left is my ASA, right? So on my ASA, right, it is again nothing but clustering, right? We are still doing clustering, we are just doing it in a different mode, right? So the bootstrap configuration which you have to do on both your ASA1 and ASA2 is something which is very important. So let me start doing that. So let me just pick it from here, or I already have it here if I'm not wrong. Okay, so R1, R2, okay, so I have it here, right? So the bootstrap configuration, the only change is going to be that I'm going to use a different mode here, which is individual mode instead of span. So let me go and edit this. I'm going to make it individual. All of this remains same, right? Priority and all of this remains same. So that's going to be my bootstrap. Similar is the case with the ASA2. I have to just go and replace this. That's done. So now we will take this and put it on my ASA1, right? Let me see if there is any cluster related configuration already on this router, because I probably did that earlier. Okay, there is nothing. So we can go and let me clear the screen a bit. There you go. I'm putting my cluster configuration, the bootstrap configuration on ASA1, I'm going to do the same thing on my ASA2. Let me clear the screen. Okay, let's see if this has show run include cluster. Okay, it's conf t, and there you go. It's good. Yeah, so now we will have to wait for my cluster to come up, right? Let's wait for a minute or so. It should be right. So it's going to come up in a minute or so. It will take some time. So once a cluster comes up, then we will go and do the other rest of the configuration on the master. All right, so as you see on the screen, the replication of configuration from master to slave has completed. You can again go and check show cluster info, and my bad, right? You get the information that this particular ASA1 is my master, whereas the ASA2 is basically my slave, right? So that looks good. Now what do? Now we are supposed to do the actual configuration on the master, right? So let's do that. So go back to my configuration file here. So this was the earlier configuration which we used in my spanned mode. So what will be the difference? Okay, so in case of my individual mode, what we do is we don't take this approach where we use port channels. Instead, like I said, we are going to use routing, right? So to start, what we're going to do is we are going to create a pool of IP addresses which will be used by the cluster devices, right? So we call this as IP local pool. On the outside, I'm going to use 11 to 15, right? So we're going to use these 5 addresses, and on the inside we are going to use 10 dot, again from 11 to 15, these 5 addresses, right? Let me also define my EIGRP, or I could do that later. Let me start with my okay. So I have my Ethernet interface here. We are no longer going to use the port channel, right? We're going to remove the port channels from here, right? So let me remove these 2 lines, whereas let me reuse this. Will I need this? Probably not. Let me actually remove all of this so that I have less confusion. Probably I'm going to use this as well. So yeah. So if you see here, we are going to have the Ethernet interface and the name if statement, right? The security level which we do normally, right? So let me remove this piece as well. So yeah, this is what goes in first. What do we do next? Let's also put the IP address. So this is how you define the IP address in case of individual mode, right? So when we define the IP address, we define a particular IP address, and then we give a cluster pool, and we are telling the interface to fetch the IP addresses from this cluster pool. So we are going to use one of the IP addresses from this pool for all our devices which are inside the cluster, right? So we will repeat the same thing for the outside interface as well. So this was the inside interface, this is my outside interface. I'm going to repeat the same thing. It's going to be Ethernet 3 outside level 0, the IP address. I'm going to attach the pool outside which I defined here, right? And the whole timer is defined, no shut, right? That looks good. The next part is the route outside, right? And we have the object pool as well, which is basically the NAT part, right? What do we do next? I think let's also define the hold timer here as well, because I'm not sure what is the hold timer used. So let me explicitly define it to be 40 seconds. And how do I do that? I can take the interface after I've defined my, okay, so I've not defined my routing yet. So let's define the routing, just like how we defined the routing here in R1, R2. Remember we did it here, R1 and R2. We're going to do the same thing on my ASA as well, right? So probably after defining this, let's go and do the routing. Here you go. So I'm basically advertising my 2 networks, 192.1.20.0 and the 10.11.11.0, right? These are the 2 networks which are going to be there, and that is why I'm advertising them. And once I do that, let me give the timers, right? The timers seem to be important. So how do I do the timers part? So I just go and pull the interface, and I will define the timer over there, hold timer. Here you go, right? And I'm going to define the other timer as well. So this one, okay, looks good. I think it does. Okay, so I think we can go and put this now. Let's see how it works out. So let me just pick this up first. This is my ASA. Okay, so after that I'm going to do this. So you need to always do the configuration on your master ASA, right? So the slaves ASA basically will get the configuration replicated from the master. Okay, so yeah, takes a bit of time. Okay, that looks good. Let me do the next piece, which is this one. So I've defined a default route, and I've also put up router EIGRP. The last part is this one. Okay, it's taking a bit of time, but yeah, you'll have to wait. Okay, that looks good. Now let's put the last piece, which is basically the hold time and also the pool. Just looks good, right? So that was the whole configuration which I had to do. And what do we do next? Let's look if my configuration is good. Show route. So I'm just checking if the routing has come up on my R1. Yeah, so you can see on my R1, which is actually down here, I have the routes for the 2.0 network, which is on my R2, and I also have so this is very important, right? If you look at, if I have to reach to my 2.0 network, I have two paths to do that, and these two paths are basically the equal cost paths, right? And that is how the whole clustering is helping the ASAs achieve the load balancing, right? So as it is, because it's an equal cost path, the traffic will be divided between these two paths, and we are able to achieve it. So how do we test if everything is working? Probably let's do a telnet. Let me clear the screen a bit, right? So just like I did this, show IP route, let me check it on other devices as well. So I will have to check the same thing on probably my R2. Let's check that on R2 if everything is good. Let me clear the screen again. Okay, let's do this. Yeah, so I have my networks here, which is good. There seems to be a little bit of an issue with the adjacency going up and down. Let me see what the issue is. Show IP EHRP neighbors detail. Okay, so I think the whole time is pretty good. Whatever we have configured seems to be working, and I think we need to have the connectivity now. So what we'll do is we'll do a telnet to 2.2.2, right? I'm gonna source it from the loopback. Yeah, there you go. I have access to R2, which means the telnet worked. right? So we did a telnet from R1 to R2 and it worked, and the traffic actually went via, you know, via the equal cost paths, right? So which means whatever we configured here in between is actually working, right? And that is the concept of, you know, the individual interface mode, right? And the difference is that here we are going to use port channels in case of the span mode, whereas when you come to the individual interface mode, we don't use port channels. We in turn use the capability of the routing protocols to give equal cost path between two destinations, and we are basically diverting the traffic or sharing or basically balancing, right? We are using the load balancing capability. Because of the equal cost path, the traffic is going to be balanced between both the devices, and that's how it works. So I think this looks pretty good, right? And we are able to telnet from R1 to R2. All right then, thanks for watching. Have a good day.